All right, let's talk about Starship. This is, without a doubt, the most ambitious rocket ever conceived. It's a machine built on the wild dream of putting cities on Mars. And so far, its story has been written in a blaze of spectacular launches and, yeah, even more spectacular fireballs. This is that story. And you really can't talk about Starship without this quote from Elon Musk. It just perfectly sums up the entire program, doesn't it? On one hand, you have this incredibly bold, almost impossible goal. And on the other, a very real, very sharp understanding of the life and death stakes that come with it. So that brings us to the big question, the reason we're all here. After years of watching these tests happen out in the open, rockets exploding for the whole world to see, how close are we really to putting people inside this giant stainless steel tube and actually sending them to another planet? To figure that out, we have to start with the why. Why even build this thing? Because this was never just about building a bigger rocket. It's about trying to completely change the game for humanity's future in space. And the scale of that dream is just immense. We're not talking about 3 or 4 astronauts in a tiny capsule. Starship is being designed to carry over 100 people at a time. So think of it less like a high-performance sports car and more like a double-decker bus for crossing the solar system. And the stakes? Well, they couldn't be higher. The grand prize, the ultimate goal, is colonizing Mars. But in the short term, NASA has bet big on Starship to land its Artemis astronauts back on the moon. If this all works, it can make getting to orbit cheaper than it's ever been. But if it fails, our multiplanetary ambitions could get stuck on Earth for a generation. Okay, so let's get into the first big phase of testing. Because before you can even think about going to orbit, you have to prove you can get a 50-meter-tall steel cylinder back to the ground in one piece. And SpaceX, they chose a pretty radical way to do it. This whole series of tests perfectly captures the SpaceX mindset. Test, fail, learn, and fly again, as fast as you possibly can. First, you had SN8, which proved the insane belly flop maneuver was actually possible, even though it ended in a massive fireball. Then SN9 blew up, teaching a hard lesson about engine failure. S10, it actually landed. And then, whoops, it exploded a few minutes later, teaching them about fuel systems. And then, just 5 months after that first fiery attempt, SN15 nailed the landing and stayed in one piece. So here's the key takeaway from all that chaos. Those explosions, they weren't really failures in the traditional sense. They were rapid, explosive data-gathering exercises. Each fireball bought them a critical piece of the puzzle that led to the final success. It proved that this build, fly, break approach actually works. So with the landing more or less figured out, it was time for the main event. Stacking Starship on top of its gigantic super heavy booster and actually trying to get to orbit. And this is where the difficulty level just skyrockets. Each of these orbital flights was designed to solve the next biggest problem. The first test? Well, the big lesson there was that the rocket's own power could destroy the launch pad. The second flight proved that their wild, hot staging idea, where the top stage engines light while still attached, actually works. The third flight made it all the way to space, which revealed the next big boss, the heat shield. And the fourth? We saw the booster make a soft landing in the ocean. The pattern is crystal clear. They are knocking down one massive challenge at a time. So this all brings us back to our big question. We've seen the progress, we've seen the fire. What's actually left on the checklist before anyone would seriously consider strapping a person into this thing? And yeah, it's a pretty serious list. The heat shield for re-entry is clearly priority number 1 right now. After that, they don't just have to land the booster in the ship, they have to catch them and prove they can be reused quickly. Then there's the incredibly difficult tech for refueling in orbit, which is a must-have for any Mars trip. And finally, they have to check every single box for the FAA's crew safety rules, a process that can take years, all on its own. And if you want to understand the timeline, just look at past predictions. Since 2017, the line has pretty consistently been that Starship is about 2 years away. Now, that's not really a criticism. It's more of a perfect illustration of the huge gap between ambitious engineering goals and the brutal, unforgiving reality of rocket science. To really get what's happening with Starship, you have to compare it to the old way of doing things. Take the space shuttle. It was developed carefully, mostly behind closed doors over decades. It flew 135 times, but 2 of those missions ended in disaster. SpaceX is doing the complete opposite. Their philosophy is to fail early, fail often, and do it all out in the open, so that by the time people are on board, almost every imaginable thing that can go wrong has gone wrong and been fixed. So, is it ready for humans? The verdict is not yet, not even close. But here's the most important thing to remember. Every single one of those spectacular explosions we've all watched online was a lesson. It was a lesson SpaceX paid for with steel and schedule, but not with human lives. And because of that, they are running what is arguably the fastest learning space program in history. Which really just leaves us with one final question for you. After seeing this journey, the incredible dream, the rapid-fire tests, the explosions, and the long checklist that still remains, what would it take for you? After how many successful flights in a row, would you be willing to climb on board and take that ride to Mars?